When we're talking about market-based solutions, whether it is carbon tax or emission trading program, establishing a carbon dividend is going to be essential. Right? And what a carbon dividend is essentially placing a price on carbon, or more accurately, place a price on the emission of carbon, and because it's recognizing that carbon dioxide as a global pollutant is an externality problem, and so market solutions that can internalize this cost, right, is going to lead to the most efficient outcome, both in terms of the emission amount, the efficient amount of pollution, and more importantly, the efficient amount of pollution reduction. Now, let's start with carbon tax. Now, carbon tax is based on the Pigouvian tax, and the simple idea, carbon tax is a per unit tax on goods and services based on the quantity of carbon dioxide emitted during the production or the consumption process. Right. Now, the idea is simple, right, because carbon is an externality from some activity. So therefore, if we can implement the externality in the form of a tax, the market can efficiently reach a market equilibrium. Okay, but the question is, what is the externality? Right? We need a dollar amount here, and if you remember from chapter 6, right, the economic value of this, the valuation of carbon, right, is really subjective, right? Because um, the cost must include all future costs and all financial, present and the future costs, right? And what are these costs? These costs are in terms of environmental damage or loss of life, right? And these are very difficult to estimate. Now, but it is still a necessary task, and so when we estimate the externality due to carbon emission, we call that the social cost of carbon. Okay, and so here is some information from the EPA website. Let's take a look. So here is an EPA webpage, or I should say a former webpage on the EPA website. Unfortunately, if you look at this warning, or not warning, but this notice on top, this is not the current EPA website. For during the Trump administration, this website was taken off. Although good thing somebody archived it, but hopefully, with the new administration, we can get this website back online. But anyway, this is the social cost of carbon. So it's an attempt to estimate essentially the externality of greenhouse gas, right? Or per unit of per metric ton, excuse me, of CO2. Okay. Now we can look at it here and just kind of let's kind of talk about the technical side of estimating this externality here. So there are many things affecting the social costs or the externality of carbon dioxide. Now, even if so, we can look at here's the technical support document. We're not going to go deep into it, but you can take a look there to see what factors were considered. Now, let's just focus on two other variables here. One is time, year, and one is a discount rate. So first, let's look at this 5% discount rate here. And what you'll notice is as the year progresses into the future, the social cost here, the per unit of carbon dioxide, also increases. Now, let's think about why this is the case. Right, this is what it's saying is in 2015, every metric ton of carbon dioxide is $11 cost, and in 2050, the same metric ton is going to be $26 emitted in 2050. Now why might this be? Well, remember, right? This CO2 emission concentrates in the atmosphere, and for every additional ton of carbon, when there is already a lot of concentration, it increases the damage, or the marginal damage increases depending on how much concentration you have already. And so in the year 2050, we're going to have a much higher concentration of carbon than than the concentration in 2015. So if you add a metric ton of carbon dioxide in 2050, it's going to do more damage than if you add a metric ton of carbon in 2015. Right. Now, if we look across here, we see that if we look across, going down in discount rate, we see that the cost goes up. Okay, now why might that be? Well, because remember, carbon dioxide, CO2 concentration, most of the damage, meaning most of the cost, is going to happen down many years down into the future. When you have a higher discount rate, that what that's going to happen is it's going to discount those costs from the future to the present, right? It's going to affect the future cost much more. When you lower the discount rate, those future costs will be valued more today. Right. And so this is what we're talking about when we said in chapter 7, about choosing the discount rate, which is very subjective because remember, right, we don't all agree on the discount rate. Discount rate is subjective. Everybody has a different discount rate. But when it comes to climate change policy, the higher the discount rate you use, the less significant, right, the impact of climate change will be. Okay. And so again, right, which one of these numbers is the right one? There's no right one, right? It really depends on what do we value. Okay. But nonetheless, in order for us to achieve the efficient outcome, we must have a proper estimation of the carbon of the social cost of carbon. So coming back to carbon tax. So when we talk about carbon tax, here's a brief side note that we must talk about the difference between tons of carbon versus tons of CO2. Now, what we care about really is, or I should say, whenever we talk about carbon tax, most of the time we are not actually talking about tons of carbon, but really we're talking about tons of CO2. Okay. I want to illustrate this by looking at two different tax. We have $80 per ton of carbon versus $80 per tons of CO2. Okay. Now, is this really the same? Okay. Now, how do I convert this? If I were told that there would be a ton the tax on carbon, how do I what is that in terms of tax on per ton of CO2? So first of all, to do that, we need to take the molar mass. Okay, so we take the molar mass of carbon, which is about 12 grams per mole, or the molar mass of CO2, carbon dioxide, which is 44 grams per mole. Once we have that, okay, we find the ratio. Okay, now what are we doing with this ratio? So here, right, suppose that we propose a tax, which is $80 per ton of carbon. Okay. Now, what we want to know is what does that mean in terms of tons of CO2? So then all we have to do then is take that $80 per ton, multiply that by 0.2727 here. That's the ratio. And then we can get to $21.81 per ton of CO2. So what that means is $80 per ton of carbon, it really means is equivalent of placing $21.81 on ton of CO2. And this is the only conversion rarely that you'll ever have to do because again when we talk about carbon tax, we're almost always talking about in terms of tons of CO2, but rarely, once in a while, you will read some literature that talk about carbon tax in terms of per ton of carbon. So if that ever happens, you would just need to use this ratio to convert this back to tons of CO2. Now, we can also go the other way. So you guys flip the molar mass around, we get a ratio of 3.667. So suppose that you want to convert 80 tons of CO2, and then you want to convert it to what does that mean in terms of tons of carbon, ton per carbon, and it would be equivalent of $293 per ton of carbon. Okay. All right. Now, impact of carbon tax on prices. Okay, so this is the beauty of carbon tax, right? Because a carbon tax doesn't really care about what type of fuel it is. All it cares about is increasing the price on the fuel that is the most carbon intensive, which is what we care about, right? So when you implement a carbon tax, right? Here we see that coal has the highest carbon content compared to oil or natural gas, and therefore we know that a carbon tax will increase the price of coal the most compared to, or relatively speaking, compared to oil and natural gas. Okay. Now, how exactly does that translate into the market? Right? Or how does that affect the market price? Okay. In order to do that, we need to do a little bit more conversion. So I'm going to switch over to our paper now. Okay, so we need to do a little conversion because we don't sell these things, all these different types of fuel by the same unit. Right? Gasoline, we buy them in gallons. Coal, we buy them in tons, and natural gas, we buy them in cubic feet. All right. Now we want the tax is based on the tons of CO2 right here, right? So it's where we want to. So the goal here again, right, is to look at the effect of a $50 tax on per ton of CO2 on the market price of each of these different types of fuel. Okay, so first thing we got to do is first we got to look at how many kilograms of CO2 per unit of these fuel. So gasoline. So now I'm going to use some numbers that our textbook provides. So a gallon of gasoline will have 8.89 kilograms of CO2 per gallon. A ton of coal is going to have 2,100 kilograms of CO2 per ton of coal, and natural gas will have 53.12 kilograms of CO2 per cubic feet of gas. Now, next, these have to be converted into tons of CO2 per gallon, per ton, and per cubic feet because our tax is in terms of ton. All right, so now we're using British ton, and so then one British ton is 1,000 kilograms. So all we're doing is dividing it by 1,000, and so that means every gallon of gas will have 0.00889 tons of CO2. Okay, divide this by 1,000, we get 2.1 tons per. So we have 2.1 tons of CO2 per per ton of coal. Okay, again, this is just to what they call the U.S. ton. This is the British ton. So that's what these are two different units here. And then natural gas cubic feet. We have again divided by 1,000, so we get 0.05312 tons of CO2 per cubic feet. To convert that into dollars of the tax per unit, simple, we just multiply by 50. 50 times this will give us 0.45. So that means for every gallon of gasoline, if the carbon tax is $50 per ton, then we will add 45 cents to every gallon of gasoline. Okay, important note, this does not depend on the market price. So regardless of what the market price is, right, a $50 tax will always add 45 cents onto the gasoline, right? And this is because this tax is depending on the physical CO2 amount that a gallon of gasoline emits. Okay, what about this? So 50 times 2.1, it's going to give us, sorry about that. It's going to give us $105 on top of the cost of coal. And for natural gas, multiply 50 times this will be 2.66. Okay, now so that's pretty useful. However, right, that still doesn't tell us the relative price change. In order to do that, and that will give us a much better sense of the effect on the prices, we need to compare that to the current price. So here I'm just going to look at. So here I'm going to use as reference some 2016. This is just convenient. 2016 prices. Okay. Again, these are market prices of these fuels, so they change on a daily basis. But in 2016, if we take a snapshot, right, for every gallon of gas is $2.20. Oh, those are good old days. right? Every ton of coal, for those of you who ever shop for coal, right? Like $40 per ton. Although, I mean, of course, most of us never shop for coal, but still seems pretty cheap for a ton of coal. But shocking but true. And then natural gas, $12 per cubic feet of natural gas. Okay, now to find the percent increase, all we have to do now is to take the tax and divide it by the retail price. So here, so we take 0.45 divided by 2.20. Then when we get 0.205, what does this tell us? It tells us that if we implement the carbon tax, it will be a 20.5% increase over the retail price. Okay, what about this? So we do the same here, and this gives us 262.5%. Okay, again, divide 105 by 40, 105 by 40, and we'll get 262.5%. That is a significant increase. And then what about for natural gas? And we're going to get 22.17%. Okay, and that's what we expected. This is what we expected, and this is the beauty of the carbon tax, right? Because coal is the most carbon intensive fuel source here, and by implementing a flat carbon tax, we're going to be increasing the price of coal by over 262%. And now what this is going to happen is the industry and the firms, right, they're going to choose. This will incentivize, right, a movement away from coal to natural gas or even to solar or wind.